Now there is a question for the measurement of the portfolio return, expected return of the portfolio. Here the question is that a portfolio consists of three securities A, B and C with expected return of 25%, 22% and 20% respectively. From this information we have to calculate the expected return of the portfolio assuming the securities are equally weighted. Here the formula for calculation of the expected return of the portfolio is that summation of weight into expected return. That means here the formula will be WA into expected return of security A. WA means weight of security A into expected return of security A plus weight of security B into expected return from security B plus weight of security C into expected return from security C. Here expected return from security A, expected return from security B and expected return from security C are provided in the question, which is 25%, 22% and 20%. Now since the securities are equally weighted and here we have hold three securities, the weight associated with each securities is 1/3. So WA, WB and WC, that means weight of security A, weight of security B and weight of security C are equal to 1/3 since they are holding in equal proportion. Now, so the expected return of the portfolio will be weight of security A into expected return of security A. Weight of security A is 1/3, expected return of security A is 25%. Weight of security B is 1/3, expected return from security B is 22%. Weight of security C is 1/3, expected return from security C is 20%. Now the result comes to 22.33%. This is the expected return from the portfolio. Now here ERP is the expected return of the portfolio. WA, WB, WC are the weight associated with security A, security B and security C, and since they are holding in equal proportion, weight associated with each securities is 1/3. Now ERA is the expected return of security A, which is given as 25%. ERB is the expected return of security B, which is given as 22%, and ERC is the expected return of security C, which is given as 20%. Now here there is another question. The return of security A and B under possible states of nature are given below. That means these are the states of nature, means the phase of economy, and probability associated with each states of nature are also given. Return associated with security A are also given. Return associated with security B are also given in different states of nature with associated probabilities. Now the question is, what are the expected return, and we have to determine also the covariance between the return of the two securities. Now here we know that in the Markovitch diversification, determination of the covariance or co-movement of the securities is very important. So here we have to try to calculate the covariance, that is co-movement associated with these two securities. Now first we have to calculate the expected return. Now here expected return may be calculated by applying the formula of summation of Pi into Ri. Probability associated with each states of nature and expected rate of return associated with each probability factor is given in the question. Now here expected return of security A may be taken as summation of Pi into Ra. Here for the first states of nature, probability is 10%, probability is 0.10 and rate of return is 10%, minus 10%. For states of nature 2, the probability is 0.30 and rate of return generated from security A is 15%. Similarly, for states of nature 3, probability is 0.30 and associated rate of return is 18%. For states of nature 4, it is probability is 0.20, and associated rate of return generated from security A is 22%. For security for face of states of nature 5, associated probability is 10% with rate of return from security A 27%. Now, what will be the expected return from security A? This will be the summation of Pi into RE. That means 0.10 into minus 10%, 0.30 into 15%, 0.30 into 18%, 0.20 into 22%, 0.10 into 27%. Now, the expected return from security A is 0.10 into minus 10% plus 0.30 into 15% plus 0.30 into 18% plus 0.20 into 22% plus 0.10 into 27%, and it comes to 16%, 0.16 or 16%. Similarly, expected return from security B can be calculated by using the formula summation of Pi into RB. Here, for first states of nature, probability is 0.10% and expected return is 5%. For states of nature 2, associated probability is 0.30 and expected return is 12%. Similarly, for phase 3, 0.30 and 19%. For states of nature 4, 0.20, 15%. For states of nature 5, 0.10 and 12%. Now, the expected return from security B will be 0.10 into 5%, 0.30 into 12%, plus 0.30 into 19%, plus 0.20 into 15%, plus 0.10 into 12%. And it comes to expected return from security B comes to 0.14 or 14%. So, this is the expected return from security A, and this is the expected return from security B. Now, we have to calculate the covariance associated with these two securities. Covariance means the joint deviation. How this is to be calculated? Here, states of nature, associated probability, rate of return from security A and rate of return from security B for each states of nature are being provided in the question. First, we have to calculate expected return from security A, that is the mean return from security A, and it comes to 16%. And expected return from security B, that means the mean return from security B, comes to 14%. Now, we have to calculate the mean deviation of the return of security A. Mean deviation of the return of security A by applying formula RA minus ERA. Now, here we calculate mean return of the security A is 16%. Now, for the first states of nature, here the mean return, here the return from the security A is 10% and mean return is 16%. Here, for the first states of nature, return from security A is minus 10% and here the mean return is 16%. So, the mean deviation, that means RA minus ERA, is minus 10% minus 16%, that means minus 26%. Here, these figures are given in percentage. Both these figures are given in percentage. Now, for the second states of nature, the return from security A is 15% and here the mean return from security A is 16%. So, the mean deviation is 15% minus 16%, that means minus 1%. For third states of nature, the rate of return from security A comes to 18%, whereas its mean return is 16%. So, the mean deviation is 18% minus 16%, that means 2%. For fourth states of nature, the return from security A is 22% and its mean return is 16%. So, the mean deviation is 22% minus 16%, that is 6%. For states of nature 5, here the return from security A is 27% and its mean return is 16%. So, the mean deviation, that means RA minus ERA, comes to 27% minus 16%, that is 11%. In the same way, we have to calculate the mean deviation of return from security B. Here the mean of return from security B is 14%, but for states of nature 1, the return from security B is 5%. So, here the mean deviation is 5% minus 14%, that is minus 9%. For states of nature 2, here return from security B is 12%, but its mean deviation is 14%. So its mean return is 14%. So mean deviation is 14%, 12% minus 14%, that means minus 2%. Similarly, we have to calculate the mean deviation for each states of nature as we did with security B. So this is the mean deviation of the return from security A. This is the mean deviation of the return from security B, and if we multiply these two, then we will get the joint deviation. And after multiplying these two, if we multiplied the joint amount, that is multiplication of these two amount, we have to multiply it with the probability factor in order to get the total deviation, and it comes to 26%, which is Pi into Ra minus Ra bar into Rb minus ERB. That means here it is mean deviation of security A, it is the mean deviation of security B, it is, if we multiply these two, we will get joint deviation. Then for determination of the average result, we have to multiply this joint deviation with the probability factor, and the result comes to 26%. So in average, the joint deviation comes to 26%, and it is called the covariance of security A and B. It comes to 26%.